Hello, this video is for Algebra 1, and it is Chapter 1, Lesson 1. The lesson's titled Variables and Expressions. In this activity, or in this lesson, our objectives are to translate between words and algebra, and then also to evaluate algebraic expressions. The vocabulary for this lesson are variable, constant, numerical expression, algebraic expression, and evaluate. So why learn this? Well, because variables and expressions can be used to determine how many plastic drink bottles must be recycled to make enough carpet for a house. A home that is green built uses many recycled products, including carpet made from recycled plastic drink bottles. You can determine how many square feet of carpet can be made from a certain number of plastic bottles by using variables, constants, and expressions. Here to the right, we have a picture of Container City. Container City is in East London, and East London is in UK. UK stands for United Kingdom. It's a development of buildings that are made from recycled shipping containers. So I'm assuming that also inside of this recycled building is recycled carpet made from plastic drinking bottles. All right, let's look at the next slide. We have our vocabulary: variable, constant, numerical expression, and algebraic expression. First of all, a variable is a letter or a symbol that's used to represent a value that can change. A constant is a value that does not change. A numerical expression may contain only constants and or operations, and an algebraic expression may contain variables, constants, and or operations. So let's go back and visit these for just a moment. Variable, in algebra, we use letters as symbols, so it's a letter or a symbol. In algebra, we use a variable whenever that value of whatever that letter or that variable represents, it can change. Constant, on the other hand, is a value that does not change. For instance, if I have 7 plus 3, let's put that here, 7 plus 3. In this case, 7 and 3 are constants. Those variables will not change. However, back up where we're talking about variables, I might have a plus 4. Well, we don't know what the value of a is. We could plug in several different values. It's possible for this value to change. A numerical expression, it may contain only constants and or operations, such as we'll use that 7 plus 3 again. In this case, I have numbers such as 7 and 3. Those are constants. And then I have an operation. In this case, I'm using addition. However, an algebraic expression is a little bit different than a numerical expression in the fact that it might also contain variables. So if we had that a plus 4, in this case, that would be an example of an algebraic expression because it involves a variable. The long and the short of it is, once we put letters in it, it becomes algebra. And the letters, we call those variables. They represent values that can change. So let's go ahead and read further. You'll need to translate between algebraic expressions and words to be successful in math. The diagram below shows some of the ways to write mathematical operations with words. So what words do we use to represent certain operations? Well, we have addition, subtraction, multiplication, and division. For addition, we use words like the plus, or sum, or increase by, 7 plus 3, the sum of 7 and 3, or 7 increased by 3. For subtraction, we use words like minus, difference, and the phrase less than, 7 minus 3, the difference of 7 and 3, or 3 less than 7. For multiplication, we might use words like times, product, or equal groups of, such as 7 times 3, the product of 7 and 3, or we could say 7 equal groups of 3. That would all represent multiplication. And finally, for division, we have phrases like divided by and words like quotient, such as 15 divided by 3, or what is the quotient of 15 and 3. So let's look at example 1, translating from algebraic symbols to words. Give 2 ways to write each algebraic expression in words. Our first one we see here. We could represent this algebraic expression using the words the sum of x and 3. We could also say x increased by 3. And probably the most obvious one would be x plus 3, using the word plus, correct? or add x to, or add 3 to x. Those are just some other examples that we don't see here. Over here on example B, we have this algebraic expression here. We could use the words the difference of m and 7, or we could say 7 less than m, or the most obvious one would be m minus 7. For C, we have 2 dot y. We recognize this as 2 times y, or we could say the product of 2 and y. We could say 2 multiplied by y. Any of those would work. And then finally, for example D, for this algebraic expression here, we could say k divided by 5, or the quotient of k and 5. Notice over here on the writing math, they have a notation here for us, and it's about the operation of multiplication and the many different ways of representing multiplication. First, this one I'm highlighting here is what you probably are used to at first, is 2xy, and where the x is a multiplication sign, letting you know that the operation is multiplication. Then you probably progress to the dot, and you recognize that as 2 times y. However, dots can sometimes be confused with decimals if you're not careful, so you could progress to the idea of just 2y. This would be 2 times y. Notice that there's the absence of an operation sign. There's no plus, minus, divide, no multiplication sign. If there is no operation symbol there, then we recognize that as multiplication. Another way to do that would be put 2 here and y in parentheses, or we could put both the 2 and the y in parentheses, or we could put the 2 in parentheses and leave the y without parentheses. Any of the 6 forms that you see here represent the operation of multiplication. So down here in the check it out, give 2 ways to write each algebraic expression in words. So for 1a, we could say 4 minus n. We could use the words n less than 4, or we could say subtract n from 4. For the next one here, we have t over 5 as a fraction. This could be t divided by 5. It could be the quotient of k and 5. Or it could be the group of t divided by 5 evenly. That one didn't sound too good, so forget that one. For 1c, we have here, it looks like addition, right? So we could say 9 plus q. We could say the sum of 9 and q. We could say q added to 9. Any of those would work. And then for the final one, well, that looks like one of those multiplications, right? We have no operation sign there, so we recognize this as multiplication. We could call this 3 times h. We could say the product of 3 and h. We could say 3 multiplied by h. Any of those would work for that one. Let's look at the next one. To translate words into algebraic expressions, look for words that indicate the action that is taking place. So we have add, subtract, multiply, and divide again. Whenever we adding is all about putting values together, combining them together, and getting a total. However, whenever we add, we're usually adding values that are not equal to one another, which is what we do at multiplication. But we'll look at that whenever we get there. For subtraction, it's all about finding how much more or how much less one thing is of another. That is to find the difference. It might often say, what is the difference? Or how many more? Or how many fewer? Or how many less? Those are all phrases that we would recognize that we might want to use subtraction in that situation. For multiplication, it's all about putting equal groups together. So if you're adding 7, 7, 7, if you're adding a whole bunch of 7s together, instead of having 7 plus 7 plus 7, it would probably be easier to just do 7 times 3. Multiplication is all about putting together equal groups. And then finally, division. It's all about separating something into equal groups. You might have a bag of candy. You got a certain number of pieces in it. You want to divide it equally among a certain number of people. Then that would be a situation where you would want to divide. So in example 2, we have translating from words to algebraic symbols. Example A is Eve reads 25 pages per hour. Write an expression for the number of pages she reads in H hours, where H represents the number of hours. Well, if she reads 25 pages every hour, and it's always 25 pages every hour, then we are indeed adding together the same value over and over again. So this is going to be multiplication. So we could do 25.h, or we could just simply do 25h. Example B, Sam is 2 years younger than Sue, who is y years old. Write an expression for Sam's age. So we're going to base Sam's age off of Sue's age. And Sue, we're given, is 11 years old. Or y, not 11, y, excuse me. So she's y years old. So let's subtract 2 from it because Sam is 2 years younger. So it'd be that number of years less than, correct? So we're taking something away. So we would do y minus 2. Finally, William runs a mile in 12 minutes. Write an expression for the number of miles that William runs in m minutes. We're going to let m represent the total time that William runs, and then we would divide that number by 12 because it's 12 minutes that it takes for him to go each mile. So if he ran 36 minutes, we would divide that by 12, and that would give us 3 miles. All right. Now that we have discussed, we got to do the examples. Almost missed out on those. So Lou drives 65 miles an hour. Write an expression for the number of miles that Lou drives in t hours. So every single hour he's going 65 miles. So we would add 65 plus 65 plus 65. And if you're saying that's multiplication, you would indeed be correct. So for 2a, we would want to write that algebraic expression as 65 times t, the number of hours that Lou drives. Next, Miriam is 5 centimeters taller than her sister, who is m centimeters tall. Write an expression for Miriam's height in centimeters. So let's go ahead and put 2b here. And now in this case, Miriam is 5 centimeters taller than her sister, and her sister is m centimeters tall. So that's going to be 5 added to m. So we would do m plus 5. And then finally, Elaine earns $32 per day. Write an expression for the amount that she earns in d days. So put down 2c here. We'll write that expression there. So every day she earns $32. It's always the same value, added over and over again. So indeed, that would be multiplication. So it's going to be 32, the money she makes per day, times the number of days that she works. Next, we're going to talk about what does it mean to evaluate. So the word evaluate. To evaluate an expression is to find its value. So whenever it says evaluate the following expressions, that means they want you to go ahead and come down to a final numerical answer. To evaluate an algebraic expression, you have to substitute the numbers for the variables in the expression and then simplify the expression. So if you were given something like 7 plus 3 and asked to evaluate it, you'd say, oh, okay, well, that equals 10. However, in this case, if we had a plus 3, in order to complete this, you would have to know what the value of a is, substitute in the value of a for 3, and then go ahead and do the addition. So that's what we're going to do with this section here, this example 3, evaluate algebraic expressions. Evaluate each expression for x is going to equal 8, y will equal 5, and z will equal 4. So our first one is x plus y. So let's go ahead and substitute for the values of x and y. X is equal to 8, y is equal to 5. Now that we've done the substitution, we can go ahead and then simplify the expression. 8 plus 5 is 13. For example B, we have x divided by z. So let's go ahead and substitute those values for x over z. X is equal to 8 and z is equal to 4. Now we know that every fraction is a division problem, so 8 divided by 4 equals 2. For our check it out down here, evaluate each expression for m equals 3, n equals 2, and p equals 9. So on the first one, this is multiplication here. So let's go ahead, and this is going to be a good place where I'm going to use the parentheses to demonstrate representing multiplication using parentheses. Now if I took m and said m is worth 3 and n is worth 2, what's that look like? It looks like 32, don't it? So instead of writing 32, let's go ahead and put the 3 and the 2 both in parentheses. And now we recognize that this is not 32, but indeed this is 3 times 2. 3 times 2 is 6. On the next one, p equals 9 minus the value of n, which is 2. 9 minus 2 Well, that's 7. And then finally, P divided by M. So P equals 9. And we're going to divide that by the value of M, which is 3. And 9 divided by 3 is indeed 3. So example 4, here we have our recycled bottles that we're going to make carpet out of. So recycling application, this is back from the first slide of this lesson. Approximately 14 20-ounce plastic drink bottles must be recycled to produce 1 square foot of carpet. So in a word problem, identify the information that is important to you. So it takes 20 bottles to make 1 square foot. Write an expression for the number of bottles needed to make C square feet of carpet. The expression 14C models the number of bottles needed to make C square feet of carpet, because it takes 14 bottles for every square foot. So 1 square foot, we could represent that with 14C. Next, find the number of bottles needed to make 40, 120, 224 square feet of carpet. So they're asking us to evaluate 14C, where C equals 40, 120, 224. So make a table. The value of C, 40, 120, 224. These are indeed the square feet, correct? And then we have our expression that we wrote for the square footage, or actually it's the number of bottles needed to make that many square feet, and our expression was 14C. So now we substitute in our values 40, 120, 224. Do the multiplication on each of these. 14 times 40 is 560. 14 times 120 is 1,680. And 14 times 224 is 3,136. And you can see here where our result is. To make 40 square feet of carpet, you need 560 bottles. To make 120 square feet of carpet, you need 1,680 bottles. To make 224 square foot of carpet, you need 3,136 bottles. Over here in our helpful hint, they talk about replacement sets. A replacement set is a set of numbers that can be substituted for a variable. The replacement set in example 4 is 40, 120, 224. And this is what we would call roster notation, using the brackets and separating each element of the set with commas. That would be roster notation. It lists every item in that set. Let's go ahead and look at our review here. Guided practice. First, a vocabulary word. A blank is a value that can change. Is that algebraic expression, constant, or variable? Hopefully you said variable. Variable is a symbol that represents a value that can change. Give 2 ways to write each algebraic expression in words. Let's go through and let's do the odd numbers for this one. We have f over 3, or we could say f divided by 3, or we could say the quotient of f and 3. For number 5, it's 9 minus y. We could also say the difference of 9 and y, or we could say 9 minus y, or y subtracted from 9. Number 7 is t plus 12. We could also say the sum of t and 12, or we could say add 12 to t. And then finally, for 9, we have subtraction. We could say x minus 3, the difference of x and 3, or 3 fewer than x. Number 10, George drives 45 miles an hour. George drives at 45 miles an hour. Write an expression for the number of miles George travels in h hours. So every hour he's driving 45 miles. So we're adding 45 over and over again. That would be multiplication. So it's going to be 45 times h. The length of a rectangle is 4 units greater than its width, w. Write an expression for the length of the triangle. Well, it's 4 inches greater, or 4 units greater than the width. So let's start with the width and add 4 inches. W plus 4. Let's do 12 and 14. We'll do those. So we are going to evaluate each expression. Remember, to evaluate an algebraic expression, we must first substitute the values for the variables. Then we will go ahead and simplify the expression. So a minus c, well, a is 3, minus, and c in this case is 2. So 3 minus 2 is 1. For number 14, the value of b is 4. We're going to divide that by the value of c, which is 2, and 4 minus 2, or 4 divided by 2 is indeed 2. And finally, for number 16, Brianna practices the piano 30 minutes each day. Write an expression for the number of hours she practices in D days. Well, first of all, this is in minutes, 30 minutes, and they want the number of hours. Well, we know that 30 minutes is half an hour. So let's write 1/2 as a decimal, 0.5. Now, each day she does that, so we're going to multiply that times D. Finally, find the number of hours Brianna practices in 2, 4, and 10 days. So first, if we did 2, it'd be 0.5. We're going to substitute for the value D. We're going to substitute 2. 1/2 times 2, or 1/2 of 2 is 1. For 4 days, let's do 0.5 times 4. And half of 4 is 2. And then finally, for 10 days, we're going to do 0.5. Substitute for D, we're going to substitute the value of 10. And 1/2 of 10 is 5. And notice how I used parentheses for where days was at, and then left the 0.5 without parentheses. Still, it works out fine that way, because myself or anybody who looked at this would recognize that this means 0.5 times 2, even though there is the lack of or the absence of an operation symbol. All right, so that is my complete presentation for Algebra 1, Chapter 1, Lesson 1, Variables and Expressions. Thank you.